Alright, I promised you that today we would have a look at a new project. And by, it seems, general consent on my channel, everybody seemed to, or nearly everybody, seemed to vote for me trying to resurrect and afterwards restore the Sanyo Cadnica portable black and white TV. And it's a TV, if I'm not mistaken, from 1964. But I need to look up the precise date because I can't remember it very well. Anyway, it's somewhere around, let's say, the early 60s. Now, as you can tell, the TV is pretty beaten up. I mean, it's scratched, it's dirty. It has been used heavily, as you can tell by all the pitting and the typical, I would say, paint droplets and stains everywhere, and the scuff marks and everything. So yeah, this TV has had a very hard life. Alright, let's have a look at the battery compartment. There's one screw for the battery compartment, so let's unscrew that. There you go. So there's one peculiar thing that I notice here, and that's this connector. Now it says that this connector, I'm trying to read it, so this connector is only for the battery pack model, and then a model number. Let's see if I can pull it loose. And I can. Alright, so apparently you can connect a battery pack to these pins here. The battery pack cover grips into these two slots you see here. Right, so the next thing I'm going to do is I'm going to unscrew these screws here. So one here, there, and then down below, here and there. 4 screws in all, I think, should do it. Alrighty. And it's held in by screws like these, so kind of self-tapping screws. The last one. Okay, the last screw. Phillips screws. Right, so now I'm going to place the set on its front end. Ah yes, okay, I might have to undo this screw first. Up. I would say M2 size. Yes, it's coming off. There we go. Alright. Well now, the case is loose. This is the inside of the case. Well, dirty, of course. And there's a little schematic on the side. Parts location. Let's see what it says. Parts location. Okay, yeah. It shows where all the settings are of the TV, you know, all the things that can be set. This is cruddy. This is really, really cruddy. It's so dirty. Okay, the speaker, and the speaker looks mechanically at least to be okay. Alright, then there's a little board down here. I'll have a look in a minute at the schematic to see which is which. I'm just visually checking to see if I can't see anything obviously broken or burned through. One thing I immediately notice is these corroded contacts here. So that might need some looking at. Alright, so this looks to me like the RF board with a flat connector on top. Okay, so I think, I'm not sure, but I think this is the power supply, and that's below the TV, that's at the bottom of the TV. This is the RF side of the TV, the tuner in other words, and then this is probably the deflection module of the TV. According to the schematic, pins 3 and 4 should be the pins connecting to the filament. So let's have a look. Alright. Okay, so this is the connector for the CRT, and the contacts look, well, reasonably clean, but I wouldn't trust that too much. Okay, so there you have it. Those are the pins of the CRT. Now, the schematic says pins 3 and 4. Now, when you look for the right pins on a tube, any kind of vacuum tube, you always need to look first for the key, which is a large space between the pins generally. So let me see, okay. So generally you see the pins here where I'm shining with my laser, okay, and you see there's more space between the top two pins there than between the other pins on the side. Alright, so that counts as a what they call a key. And you always, when you look at the bottom of a tube, which we are right now, you always count from the key to the right, so clockwise. So this is pin 1 where I shine my laser, and the next one is pin 2. So let's look for pin 3 and 4. 1, pin 2, pin 3, pin 4. Pin 3 is here. Okay, and pin 4 is the next one. Right. Okay, so now what I'm going to do is I'm going to have a look at the resistance of the filament. Let's see. Alright, so it says the resistance says, or the resistance measurement says 33 point, these reflections. Okay, the resistance meter says 32.1, a bit less maybe, but mind you, the contacts of the CRT are dirty. Still, we measure a resistance, let's say roughly speaking around 30 ohms. So my guess is the filament of the picture tube is probably okay. So what I'm tempted to do now is to connect up the TV to my lab power supply and give it a very slow power up and see whether we get some sort of life sign out of the TV. Alright, I hooked up my Vicky as a power or let's say current meter to the TV set. So let's give it a try. So my lab supply is at 0 volts for the moment. So let's power it up. Alright, here we go. Power on. Now let's turn up the voltage to, well, let's say a few volts. Oh, I heard the relay of my lab supply switch off, which means that it automatically limits the current. And let's see, we're at 3.3 volts, 5 volts. Yeah. Yes, I think there is a short circuit in the TV set, which makes, of course, for the lab supply to immediately shut down. Alright, so this is the power supply of the Sanyo TV, and as you can tell, it's quite a simple power supply. Now here you see the battery pack that would be normally inside the TV. Now remember, I hooked up my power supply to these two pins here. Alright, and these pins run, at least this pin here, the lower one, runs all the way up to here. Now here is the 750 milliamp fuse, and if you look a bit further, there's a symbol for a electrolytic capacitor right here, and I'm suspecting this electrolytic to be short-circuited. So what I'm going to do, I'm heating up my soldering gun, and in a moment I'm going to unsolder this capacitor right here, which is a 2000 microfarad capacitor. And once that's done, we'll measure it and we'll see how it performs. Now, before I can take out that capacitor, so here is the power supply PCB of the TV, I need to solder this little capacitor loose from the chassis, and then I need to take out 4 screws, so one here, one there, and then down there, one here, and one over, let me see, well, actually 2 over, I should say. These 2 here need to be loosened up. Now there's one more detail I want to draw your attention to, and that's this little corner here of the power supply. Now if you look closely at it, let me show you. Come on, focus. There. You see how corroded all of this is? So I'm suspecting something must have happened here. So maybe, possibly, part of the problem might also be here. And as you notice, there's also quite a big electrolytic right here. So yes, I think the source of the problem, well, part of it is the fact that this electrolytic right here, the 2000 microfarad, is short-circuiting. I undid the 3 corner screws as well as these 2 screws which attach this heatsink to the chassis. Now, as you can tell, it's hanging loose, but it's still held up, and it's held up by this wire binder here and a wire binder there. Let's see if I can pull it gently loose without breaking anything. Okay, here we are. And there you go. That's part of the power supply. Oh my, that 2000 microfarad is really a chunk, a big chunk. So this one here, right here, that's a really, really big capacitor. Although visually speaking it looks okay, there's of course absolutely no proof that it is okay. Come on. Okay, that should do it. Let's see if we can pull the capacitor. Yep, we can. There we go. Okay, give me a moment to hook up my multimeter and then we'll have a look at the capacitor. According to the schematic, that capacitor should be 2000, come on, focus. That capacitor should be 2000 microfarad. Alright, so if you look at the multimeter says 3.182 millifarad, or in other words 3182 microfarad. So that's well over, let's say, the 10% tolerance. Now just for reference, this is a brand new 25 volts 2200 microfarad capacitor. Okay, so let's hook that one up and see how it measures. Dicky. Okay, got the new capacitor hooked up. Right, so that one says 2.386 millifarad, or 2386 microfarad, which is much closer to what it should be. Okay, so what I'm going to do next is, since I unsoldered already one of the pins of that capacitor, I'm just going to unsolder it completely and then replace it by a new capacitor. Notice the difference in size. So I replaced two electrolytics in the power supply. This one here and this one here, because I thought that these two capacitors might be the cause of a short circuit, but it turns out neither replacing either of them has resolved the short circuit in the TV. Now we don't know if the short circuit is in the power supply or further on in the TV. So what I'm going to do now is I'm going to detach the power supply from this point here, and this point is labeled P12, and I am going to detach it from this point here, which is labeled P11. Alright. Okay, so here's a mystery for you. I'm pumping in 15.2 volts into the battery connector on the print board. Alright, so that I'm doing. Now I'm monitoring the current that flows from the power supply to the power supply board of the TV, and I'm also monitoring the voltage that comes out of the power supply board of the Sanyo. Okay, so now the TV is off. If, however, I switch the TV on, the voltage drops, and that's very peculiar. Okay, and also it doesn't seem to draw any current at all. So I'm measuring at the output pin of the power supply board, which is, as you know, pin P12. You see it where the yellow connector here is connected to. Alright, and right now, well, the TV is on, quote unquote, and instead of, let's say, the prescribed I'd say 11.5 volts I get about 160 millivolts. So there's something really strange going on here. Now you'll see on the schematic here that there are certain voltages written down. So the base of the power transistor that regulates the voltage should be at 14.7 volts. Okay, so the base of this transistor. Well, the base of that transistor is right here. So let's measure the voltage. .19 volts, so 190 millivolts, and that's it. Okay, let's measure on. The emitter of the driver transistor, which is this one here, should be at 4 volts exactly. Alright, so the emitter of that driver transistor is down there. Okay, so let's measure the voltage there. And I get 20 millivolts. Okay, it becomes even weirder. The base of the driver transistor should be at 4.6 volts. So 0.6 volts higher than the emitter, which would tend to indicate that this transistor, by the way, is a silicon transistor. Okay, so the base should be at 4.6 volts. Let's have a look. Base is here. Okay, and I get barely 210 millivolts. Okay, so there is something really strange going on here. Oh, and by the way, so if I connect the multimeter to the output of the power supply of the Sanyo, okay, well, when it's on, I measure 210 millivolts. Now watch what happens when I switch it off. Okay, it drops a little, but it seems to maintain its voltage at 140 millivolts. Maybe that's a capacitor discharging, I don't know, probably, but still it's a bit weird. So right now I'm a little bit conflicted as which direction to go on. I would tend to say that maybe our possible next candidate for an error would be this diode right here. Now I looked it up in the service manual. The diode D13, which you see here, is a Zener diode. They don't say the value it has, but I suspect it must be a 4 volts diode, Zener diode, so keeping the voltage at 4 volts. And that's what I think it is. Now, if this is shorted, of course, this diode here, then the output voltage is led to ground through a 330 ohms resistor. This one here, R704. Alright, so I'm beginning to think that maybe the most likely candidate for, let's say, an error would be this Zener diode right here, D13. Because like I said, if it's shorted, it will short the output voltage right straight through R704, that 330 ohms resistor, to ground. So leaving, of course, very little voltage on the output, which is exactly what we measure. So, of course, if this isn't the culprit, then we'll have to see whether some of the resistors here might cause a short to ground, possibly. But it can't be this capacitor or this one, since I replaced those. So yeah, well, D13 is located right here. So I'm going to unsolder D13 and have a closer look at it. Alright, so just to be sure that I was measuring the right values while debugging the power supply board of the Sanyo, I put a 10 watt 10 kilo ohm load on its output just to make sure that it's properly loaded. Now I have replaced yet again two components. So I replaced the Zener diode, which was here, by a new one of 3.9 volts, 1 watt. And I also replaced a small capacitor down here of 10 microfarad. The 10 microfarad was more than double its value, so it needed replacing anyway, but I was fairly sure that wouldn't do much. The Zener diode, on the other hand, I thought might be a cause for short-circuiting. Now, the strange thing is that the power has come up. So if I measure the output voltage, now I'm reading 15.1 volts at the output of the power supply. Okay, that's good, that's great. But if we look at what the schematic calls for, so let's see, come on, focus. So the schematic says that the voltage at the base of the power transistor, which regulates the voltage, should be 14.7. Okay, so the output voltage is, let's see, 15.1. okay, so the base of the power transistor is 15.1. okay. Okay, now it also says that the voltage, come on, focus, yeah, it also says the voltage at the base of the driver transistor, which is this one here, should be 14.6, and at its emitter it should be 4, so 4.6, 4. Let's see. So the base should be 4.6. And it says 14.2. Oh dear. Okay, so let's measure the emitter. The schematic says it should be 4. And we're measuring 13.75. Okay, now 13.75 at the emitter and 14.25 at the base. That means there is a voltage difference between base and emitter of, let's say, a little bit more than 500 millivolts, which I would tend to say indicates that the driver transistor right here is probably okay. So we have to look, well, another possible source of the problem, at the output of P12. You'll remember P12 is the output of the power supply, which is that point right there, okay, marked with red. Now the schematic calls for 11.5 volts, and the voltage I'm getting right now is, let's see, the voltage I'm getting is 12.5. So it's better, it's certainly better, but it's not quite good yet. So to quickly recapitulate what I did was I replaced this capacitor here. I also replaced the big one here. You'll remember this was a 2200 microfarad, which had practically doubled in value, and then this one, which was a 1000 microfarad, which had also risen in value. And I also replaced a tiny little electrolytic here of 10 microfarad that measured 22. Okay, so I also temporarily tried a new Zener diode here, and it started to work, but really not, the voltages were off, okay, and at closer inspection I probably made a mistake and inserted a new Zener diode that was too low in value. I used a 3.9 volts, but I made a reasoning error. I thought that I read the voltage here, okay, at the base, at the emitter of the driver transistor here, and I read 4 volts, and of course I assumed that this was the voltage of the Zener diode, but in effect the Zener diode is not a 4 volt Zener diode, but more than likely a 7 volt one. In any case, just out of curiosity, I reinserted the original Zener diode, and the voltages are much closer to what it should be, but not quite yet what they really should be. So you'll remember that the base of the driver transistor, which is this pin here, according to the schematic, should be 4.6 volts, and that is pretty near what it should be. However, the emitter of the driver transistor should be at 4 volts, and it is not. It's at 4.95 volts. Now I did measure all the resistances on the board, and quite a few are really off value, and I mean by quite a bit, so more than 10%. So I'll replace probably a few of those resistors. So this voltage divider here, I suspect that the values of the resistors in here are seriously off. So I'll certainly replace these, and I might even replace this one here. I might replace this one as well, because it's almost double in value. I started to have a closer look at the whole power, let's say the input power circuitry, okay, and okay, you could say I made a rookie error by not checking it out first, because, well, when I had a look at the schematic, I assumed that you see here is the input of the power, okay, so this is the power connector at the back, so that one there, okay. So I assumed that since the switch, the on-off switch, which you see here, was connecting through ground either of the connector or of the battery pack to the rest of the circuitry, that it would be fine to connect the ground of my lab supply anywhere to ground. But like I said, I made a rookie error in not checking out whether the contact you see here on the power connector was still good, and whether the switch, the on-off switch, which you see over there, was making good contact. And the power connector you see here, in fact, was making, let's say, reasonably well contact. Okay, so I had to clean it out a bit with contact cleaner, but basically this was, let's say, okay. However, what was not okay, and I should have done that right at the start, was the switch itself. Okay, so it turns out the switch was, well, most likely very, very dirty and corroded inside. So I flooded it with a really large amount of contact cleaner, and I rotated the switch, I rotated the switch on and off quite a few times, okay, until I started to measure with my ohms meter a very low value. So I don't know, 1 or 2 ohms or something like that. And having done that and connected the power supply not to the battery connector you see here, but to the actual power connector, which is here, it suddenly started to work. Okay, so there are no shorts and the voltages are, let's say, reasonably well within what it should be, but we're still not there yet. So the next thing I'm going to do is, like I said, I'm going to replace the resistors of the divider bridge here and this one here, and then we'll have a closer look at the voltages. Now there is one last thing I want to show you, and that's underneath the yellow crocodile lead you see a little potentiometer. Okay, now with that potentiometer, with this potentiometer here, you can set the output voltage here. Now obviously I did try to turn the potentiometer because, well, according to the schematic I should get 11.5 volts, which you see here. Okay, so yeah, let me show you. Okay, here we go. I'm going to turn the potentiometer. Have a look at that. Okay, I'm at one end of the potentiometer. Now let's go the other end. Okay, so you see the voltage rises. So, okay, you could say the potentiometer works, but I can never get it lower than, say, 12.6 volts or so, and then I'm really butting against one end of the potentiometer. This one here, the lower one, is brown, green, red. So that's 1, 5 and 2 zeros. So that should be 1500 ohms. Okay, 1.5 kilo ohms. So let's see what the meter says when I measure it. Alright, I'm touching the resistor now. Okay, 2.3 kilo ohms instead of 1.5 kilo ohm. So that's not too good. Okay, next, those reflections. Okay, the next resistor I'll show you is the one on the right, brown, gray, brown. So that's supposed to be 180 ohms. So that should be 180 ohms. Touching now. Oh, 0.31 kilo ohms, so 310 ohms. Ho ho. Orange, orange, brown. Alright. And to be precise, the orange, orange, brown resistor, so the 330 ohm resistor, is the one you see down there, okay, in the center of the image. Touching now. 0.59 kilo ohms, so, or 5.8, so 580 ohms and not 330. So yeah, it's, the resistors are pretty lousy, so I replaced those. Alright, so remember, when you look at the schematic says that the base of the driver transistor, so this one here, should be at 4.6 volts and its emitter should be at 4 volts. Alright, so the base of the driver transistor is here, is this pin here. Alright, so that's the base of the driver transistor. 4.56 volts, okay, and the schematic says it should be 4.6, so a little tweak and we'll be there, okay. Now the emitter should be at 4 volts. Alright, let's have a look. The emitter is here and we're measuring 4.05 volts. So that's really nice. Okay, there's another voltage that we should reach, and that's the base voltage of the power transistor, and that should be 14.7. Alright, so the base of the power transistor is here. Let's measure. And that's 15.03. So it's a little too high. Now, mind you, the whole power supply board is disconnected from the rest of the chassis, which means that there is actually no load on it, and therefore the voltage we measure at P12, so you'll remember P12 is the output of the power supply, right here where it says red, okay, the voltage should be technically 11.5 volts. So let's see what's on P12. So I connect the yellow crocodile lead to it. So here we go. So remember, there's no load on the power supply, alright? So now if we look at the meter, it says 14.64 volts. So yes, that's quite a bit higher than the 11.5 that we should have, but I'm pretty certain that once I connect up the power supply board to the rest of the chassis, that voltage will certainly drop within the desired range, or very close. One of the red leads that is connected normally to pin P12 of the supply board, the power supply board of the Sanyo, goes in fact, according to the schematic, directly to the filament of the picture tube. So if I can show you, let's see, come on, focus, yeah. So you see that little arrow here just above my thumb that points to pin 3 of the picture tube, okay, and it says P12 in fact, okay. So right next to the arrow you can see P12. So in effect it comes from that pin, okay, and you see a little arrow. I hooked up my lab supply, and it's at 0 volts for the moment, to the filament wire. Okay, I just measured it out, I ohmed it out, and I found out that the pin 4 is actually connected to the chassis of the TV, and pin 3 is connected directly to this red wire here. So I'm just curious to see whether the filament will function. So what we're going to do is we're going to switch off all the lights, and then we're going to ramp up the voltage to the filament very slowly. So I would say in increments of, let's say, 2 volts or so. Now we're getting into dangerous territory here, so now I'm going to increment it by, say, 1 volt or so. Okay, 7 volts. Ah yes, I can see a faint glow right down there. Let me see if I can show you. There. You see? That that very faint little dot? Okay, let me pull up the voltage to 8 volts. So now I'm going to pull up the voltage to 9 volts. And now I can very clearly see the glow, and so can you, I think. So yeah, I think the filament will be okay. So let's go to 10 volts now. Oh yes, now it's pretty bright, and you can tell for yourselves it's bright. Alright, so there's every chance that we'll succeed in making the CRT produce at least some kind of image. Alright, I hooked up the chassis to my lab power supply over there, and I'm going to switch the TV on gradually via my lab supply. Okay, I'm going to slowly raise the voltage from 0 to somewhere between 12 and 15 volts DC. Now, it's not too dramatic should it exceed by 1 volt or so the prescribed voltage. It isn't a drama, but obviously I would like to keep the voltage as tightly as possible within the prescribed limit. In any case, the set is all ready to be switched on, and okay, I switched it off now, and just in case the set would show some signs of life, I also prepared my pattern generator, okay, my leader 408 NPS pattern generator, to inject some radio frequency signal into the TV. But I mean, maybe we're getting ahead of ourselves now. Let's see first if the whole thing will work, because there's every possibility the TV simply won't switch on at all. But since the power supply now seems to work reasonably well, I really think we stand a good chance of getting it to work, all of it. I'm guessing we might also hear maybe sound, maybe not. I kind of doubt it, but you never know. So what you're going to see now is what I am going to see for the first time. So it will be a surprise to the both of us. Maybe the set might even go into a poof of smoke, which would certainly make Shango very happy. Here we go. Switch on the power supply. Alrighty. Well, everything is at 0. These reflections. I hate those reflections. Let me see. Okay. Fine. Right, so let's set the lab power supply to, I'd say an initial 5 volts would do. There. Okay. And now let's switch on the set. Alright, the voltage on P12 is low. Yeah, I would say 1.2 volts. Okay. Well, let's turn up the voltage a bit. Let's say to 7 volts. Alright. That's the voltage at P12. That's mighty low. I would have expected the voltage to rise quite a bit higher. Okay, well, let's go a little bit higher. Up to 9 volts. Oh, suddenly everything shot up. Okay, we're at 9 volts and the TV is now consuming about 250 milliamps and the voltage at P12 went up to 8 volts. Let's see if we can hear anything or see anything. Well, I'm not hearing anything, except the blowing of my lab supply, but not seeing anything, not even an image or anything. Okay, let's have a look at the filament of the picture tube. Oh yeah, I can see it glow faintly, but it's not very bright. Okay, well, we're at 9 volts, so let's go to, say, 10 volts. Right, the voltage at P12 is 8.80 or thereabouts. Okay, I don't see any smoke, but I don't hear any noise either. There's no sound, there's no brightness, there's nothing. Okay, well, that's a bummer. Alright, let's see. The voltage is at 10 volts and the current is now 290 milliamps. So let's go to 12 volts and see what happens. Guys, look at that. We have an image, but oh dear, it's so dark, so faint. I mean, it's brighter on the camera, but it's very faint on the set itself. But hey, that's a nice result, but no sound. Sound is completely dead. Well, okay, the guy told me that there was no sound and no picture, so... Alright, well, the input voltage should be around 15 volts, they say. So we're now at around about 12 volts. So let's go to 13 volts. Okay, that's the voltage at P12. And the screen is maybe a little bit brighter, but not by much. The horizontal and vertical deflection seem to work though. Yeah, but the sound is dead. Completely dead. Okay. Well, let's go to 14 volts. Come on, focus. There. Well, the screen is marginally brighter, but okay, I can see snow now, so that's okay. Yeah, there might be some sort of signal coming through on it, but I don't know. In any case, I think the tuner works. Yeah, the tuner works, but the sound doesn't. Right, the voltage at P12 is a bit on the high side. It's 12.6 and it should be somewhere around 11.5. Maybe a bit higher wouldn't hurt, but 11.5 would be the right voltage. So let's see if we can bring that down a little bit. Okay. No, I can't seem to bring it down a lot. Okay. Well, let's go up to 15 volts as they preconize. Oh, now that is pushing the TV hard. Okay. The TV draws 450 milliamps now, and the voltage at P12 is 13.3, which is really a bit high. It won't kill the TV off, really, but, well, it's a bit too high. Okay, no sound. So, right, well, now at least we know the the video part of the TV works, so that's a good sign. But now we need to fix the sound. Well, let's get searching for sound now. Alright, I hooked up the set to my pattern generator, and I'm outputting a convergence, which is pattern which is more like a raster or crosshatch pattern, and I'm also injecting the circle, which you see faintly, but you do see it. If I switch it off and on, I'm sure you see the circle. Now the image is very distorted and, well, bad quality. You know, it's shaky, and it is there, but it's not good. Also, I'm injecting a sound, as you can tell. Alright, so I'm injecting a sound, and the sound is, let's see, it's a 1 kilohertz signal, but obviously we're not hearing anything. I mean, absolutely nothing. Now, I did listen with my sound probe, or my signal probe rather, and even with a very sensitive signal probe, I'm not getting any signal. Before you start looking to replace something, well, I mean components or anything, the very first thing you should do is check out a few components. Now, I did replace all the electrolytics, alright? Why? Well, because in my experience I've noticed that electrolytics are, well, really rather evil things when they turn bad. And if you have electrolytics that are, say, 40 or 50 years old, you can bet that they are probably bad. So it wasn't even a question, I just replaced them. All in all, there were only 5 electrolytics to replace, so that's no big deal. Alright, so then next I proceeded to check the resistors in circuit, which means that I left the resistors of the amplifier on the PCB, and I started measuring them one by one. And you can see I made with a pencil little marks, little V's that were checked out okay, and I crossed those that were bad, and there are quite a few that are really bad. Alright, so here are a few of the resistors I replaced. Now, for example, the upper one right here, okay, is the color code is red, red, brown. So red is 2, so you have 2, 2, and brown is 0, so that's 220 ohms. Alright, let's measure the 220 ohms. Okay, so touching now. $383 ohms. Okay, blue, gray, brown. Okay, and blue, gray, brown is 680, so 680 ohms. Let's measure that one. There you go, 1100 ohms. I ended up by extracting the original power transistors that were inside the TV, and I'm showing you what I extracted. So I extracted the two the two SB22, yeah, which is a PNP, and then I extracted the two SD30. I think it's SD30, yeah. Okay, so I extracted the two SD30. Alright, so, and I'm sorry, this is the PNP, this is the NPN, okay? And I replaced them. They are both germanium. Now, the trouble is, I don't have germanium transistors with the same form factor. Okay, I don't know exactly, this is not TO92. In any case, the form factor, I do have replacements, theoretically, germanium transistors, but they have the wide TO3 housing, okay, so the low fat ones instead of the slim high ones. So I couldn't use those, and therefore I reverted to using standard silicon transistors, which is an BC547 NPN and a BC557 PNP. Alright, so yeah, it's not ideal, but it will probably work fine. Now, I connected up my small test speaker to the output of the amplifier. So now we're going to switch it on, and then I'm going to show you what the result is. I hooked up a small signal generator, which you see here, which generates an oscillating tone, and I mean by that going between 400 and 1 kilohertz, 400 hertz, 1 kilohertz. Now let me show you what happens when I inject it to the base of the preamp driver transistor. Okay. There you go. So when I inject a tone or a signal, a sound signal, into the base of the preamp transistor, you can hear it from the speaker. So I would say I did repair the output of the TV, although it's not perfect, of course, since, well, I'm using silicon transistors for the output instead of germanium ones, which will make me have to look for a solution to optimize that. Also, the speaker I'm using is 8 ohms and not 60 ohms. Alright? So, well, it's not ideal, but it seems to work. So now what I need to do is to see whether I can send a tone over with some video signal and see whether the IF circuitry is putting through the sound. So let's do that. I'm injecting a video signal into the RF input of the TV, and I'm also injecting a sound with it. Okay, so as you can see, I'm injecting a 1 kilohertz sound into the TV, and it is there. But it's incredibly faint. So I need to find out how I can improve on the sound quality. Alright, so there is sound coming from the amplifier. You can hear it crackle. And if you listen carefully, you can even hear the tone I'm sending through the RF. But, well, it's very faint, of course. Still, I did manage to repair the power supply, and the output of the TV, I mean the sound amplifier, really. So, although I admit it, there is still some work to be done on it. Also, we have a rather good image on the screen, albeit a little bit faint. I mean, okay, on the camera it looks bright, but in reality it's rather dim. Yeah, so in reality it's more like this. Okay, so this is what you would see in real, so about there. So that's how dim it is in reality. Now if I turn the brightness up, that's what you see in the camera, okay? But really, that's way much brighter than what it is in real. Okay, so I would say the restoration, or rather I would say the resurrection of the TV is a success. Keeping in mind that, well, the seller told me that the TV was basically dead. Okay, so no sound and no picture. So we've come a long way. So for all of you who would like to see me completely restore the TV, just keep looking. I think I will place one or maybe 2 more episodes on the Sanyo. So yeah, I would say if you have any comments or questions, put them below the video. Please give me a thumbs up if you liked this video. Subscribe if you haven't already. And well, I would say thanks for watching.